Hello friends, now the last but important topic of feedback amplifier is the analysis of BJT and FET based feedback amplifier. Before we proceed for the analysis of the BJT and FET based feedback amplifiers, we must know the steps involved for analysis. I'll be discussing the different steps which are used for analysis of the amplifiers, and then we will proceed with the practical circuits. So let us see the steps one by one. I'll be discussing one by one, that is steps of analysis. First step, you can see the first step of analysis, identify the topology of feedback and obtain the feedback factor. So for analysis, the very first step is to identify the topology of feedback. What do you mean by topology of feedback? The meaning here is we need to know whether it is voltage series feedback or current series feedback or voltage shunt feedback or current shunt feedback. From the circuit, we need to identify the topology first, and then from the topology we need to identify the feedback factor, or we need to calculate, or we need to obtain the feedback factor. So for identification of topology, there are some set of rules. We need to observe the following rules from the given circuit. The following needs to be observed from given circuit to identify the topology of the feedback. Let us see these rules one by one. If the signal XF, what is signal XF? Signal XF is feedback signal. If signal XF is applied in series with input signal or loop, input signal or input loop, then it must be a series or voltage mixing. You should be knowing, or you should be able to identify whether the feedback signal is being transferred on the input side in series with the input loop. If the feedback signal is in series with the input loop, and in series, that is a voltage mixing. And if feedback signal is in shunt with the input signal, if that is coming in shunt with the input signal, then it must be shunt mixing or current mixing. Of course, we will be able to understand it better way after after discussion of the practical circuits. But you should be knowing the set of rules, because if you know the set of rules, only then you will be able to analyze the circuit. Fine. So second part is, if sampled signal X0 is taken from output voltage node. If sampled signal X0 is taken from output voltage node, then it must be a voltage or shunt sampling. And if sampled signal is taken from output loop, then it must be a series or current sampling. We will see that one by one, but just you need to remember certain steps, the steps to be followed for the analysis. Now the second step is identify the input and output circuits without feedback loading using the following rules. Again, you need to use the set of rules to identify the input and output circuits. Means basic purpose here is we need to separate input side and output side. We need to remove that feedback component. So that is the meaning of this second rule, that identify the input and output circuits without feedback loading. We will see that, of course, once we talk about the practical circuit. Let us see the rule. To find the input circuit, set V0 equal to 0 for voltage or shunt sampling. So if it is voltage or shunt sampling, set V0 to identify the input circuit, and set output current I0 equal to 0 for current or series sampling. Now rule 2, to find the output circuit, set Vi equal to 0 for to find the output circuit, set input Vi equal to 0 for shunt or current mixing, and set input current II equal to 0 for series or voltage mixing, and then identify the output circuit. So these are the set of rules. Fine. For identification of input and output circuits without feedback loading. Then what do we need to do? Draw the circuit of amplifier without feedback loading using, of course, these two steps. Fourth one is use Thevenin theorem to find the input source in case of voltage or series mixing, and use Norton's theorem to find the input source in case of current mixing. That is the fourth rule. Fifth, replace active device BJT by its equivalent parameter model. That is basically small signal model, you can say. The last one is calculate gain of the amplifier without feedback loading from the network drawn in step 5 by using KCL and KVL. Here there is one more thing to be mentioned here. We need to find the gain without feedback loading, input resistance and output resistance, and finally we need to obtain the desensitivity, and then of course the input resistance with feedback, output resistance with feedback, gain with feedback by using these set of rules. So these are the steps to be followed for analysis of the feedback amplifier. Now we will be talking about, that is, voltage series feedback amplifier. That is the first amplifier to be discussed. We already discussed about the different topologies of feedback amplifiers. So first we will be talking about voltage series feedback amplifier using BJT. The simple circuit of the voltage series feedback amplifier is, you please see it carefully. This is the circuit. I can you can just identify the circuit. This circuit, the circuit here is, I repeat, the circuit here is, this circuit is basically a voltage follower circuit. What do you mean by voltage follower? Or rather than saying voltage follower, that is basically emitter follower circuit, where the output is being taken from the output terminal here. This is the point where we are taking output. Fine. Now see this circuit carefully. On input side, the output voltage is the part of this loop. This is the loop I am talking. This is the output voltage is appearing in this loop, and this is nothing but the part of the input loop. This is input loop. If you take the base emitter loop is input loop. So we need to put arrow here. This is common emitter configuration. So output voltage itself is nothing but feedback voltage. I repeat here, the feedback voltage Vf, which is being fed in the input loop, is equal to output voltage itself. Fine. And you know what is beta? Beta is nothing but the feedback voltage by output, and this is equal to, if both are same, so this must be equal to 1. Now you can please see here, identification of topology of the feedback. First step, how do we identify? The output voltage is being sampled wholly, completely. The sample, we are taking the sample of this output voltage, and feedback signal is becoming this voltage itself. So that means voltage sampling and voltage mixing. We are taking this whole voltage into the input loop. So we are sampling the output voltage, and of course this is voltage which is coming in the loop of input loop of the input source. So that is why we will say this as what I said, voltage is sampled, right? Voltage sampling. Why? Because I am taking whole of the output voltage from the output terminal, and that output voltage is appearing in the loop of the input circuit. So because of that we call it as voltage mixing. Why? Because that feedback voltage is appearing in series with the input voltage. So that is why we call this as voltage mixing. and you know voltage sampling, voltage mixing on input side is known as series mixing. Fine. So this is voltage series. Although name itself right in the beginning we have already given the name voltage series feedback, but of course from this circuit you can identify that it is a voltage series feedback amplifier. We have voltage mixing on the input side and we are taking voltage sampling from the output side. Output side is nothing but this side, and that whole of the output voltage is appearing in the input loop. So we say the feedback voltage is the output voltage itself, and since it is appearing in series with the input voltage, so that is why we call this as series mixing. So that first step I was talking about, that first step is this one. So that first step we have already completed. Fine. That is, this is voltage series feedback, and beta I have already calculated here. Beta is 1, and that beta is 1 here, that is given to you. Right. Now, identification of input circuits and output circuits without feedback loading, that is the next part we will be talking about. Fine. So let us see that one by one. So let us remove this part, that's not needed, that curtain is not needed. Identification of input circuit without feedback loading. Now you need to go back to the rules. In case of identification of input circuit and output circuit, let us go back to the rules, then I will come back to this step. Identification, you see this rule, identify the input and output circuits without feedback loading. To find the input circuit, set V0 equal to 0 for voltage or shunt sampling. Fine. For voltage sampling, set V0 equal to 0 for identification of input circuit. And in our circuit, you please see, in our circuit we are taking output voltage at the sample. Voltage sampling is known as shunt sampling. So we need to set V0 equal to 0. It means I need to set this for identification of input loop. I need to set this input voltage equal to 0. So how do we set input voltage equal to 0? You simply connect this output terminal to the ground and see the circuit. How to identify the input circuit? We see the circuit. In input is this loop. So in this loop we have voltage source Vs, we have this resistance, come this way, and this resistance Re is bypassed, and if resistance Re is bypassed, so this circuit becomes the input circuit. So in input circuit we have voltage this Vs, we have this resistance Rs, this part of BJT, and this resistance is short circuited. Now let us move ahead. So let us see that circuit now. I have already drawn this circuit. So this is the circuit without feedback loading, input circuit without feedback loading. We have the source Vs, Rs, and that resistance Re is bypassed. So this, if this resistance is bypassed, so this will be the circuit without feedback loading, input circuit without feedback loading. Now we need to identify the output circuit without feedback loading. Output circuit without feedback loading for voltage mixing. And let us go back again. See the rule. To find, I'll just zoom in. You can please see this is there. To find the output circuit, set Vi equal to 0 for shunt mixing, and set I in equal to input current equal to 0 for series mixing. In our case it is series mixing. That was a series mixing. For series mixing I need to set what? I in equal to 0. Fine. So let us go ahead. This is the circuit. I am drawing just output side, this circuit, this side, collector side. Please, collector ammeter side of the BJT is nothing but collector to ammeter base circuit. This part of the circuit is output circuit. This part of the circuit is input circuit. So I am trying to identify this output circuit without feedback loading. So what I do, for series mixing, I need to set input equal to 0. and when input current is 0, so that means this is open circuit. Input current can become 0 under only one condition, when your input circuit is opened. Fine. So I have opened the input circuit here. Fine. So now let us see the output side. So when input circuit is opened, so the current coming from collector side is IC. So what will be current here? We have set I in equal to 0, so it will be collector current only. So the output circuit, now you can take this side upward, this side downward, and that voltage can be connected like this, that voltage VC. You please see, I can connect this like this. So RC is that circuit is taken like this. This is RC. So current IC was coming from supply to RC, then IC. So current, this VCC, RC, and that IC is coming. Now I have turned that upward. So what is the terminal near emitter? The terminal near emitter is this X. And what is the terminal near voltage negative and Y? So that is Y. So this circuit, what I have done, I have taken the complete output circuit. So this circuit is output circuit without feedback loading. So you can see this was shorted for input circuit. So this is shorted for input circuit. So this is input circuit without feedback loading. We have removed that, because for input side that is shorted, and for output side that appears in the output light. You can see for output side that is appearing in the path of the IC. So it is appearing in the path of current IC. You can see that part, right? So I have taken this resistance RE on the output side here. You can see here I have taken it on the output side. So this complete circuit is known as the circuit without feedback loading. Fine. So that complete circuit is known as circuit without feedback loading. I'll just make it clean so that it's clear to you. Fine. So this circuit, that resistance RE appear in the output loop but not in the input loop in case of voltage series feedback. Fine. I hope concept is clear. Now the next step here is what you do. You replace this BJT by its small signal model. When you replace it by its small signal model, so on input side this is the resistance RHIE, and from collector side this is HFE into IB, that is current dependent current source. And of course we have RS and VS here, and this side I have RC, I have RE. So that part is as it is. But remember, for small signal model, this DC source is replaced by short circuit here. So that is replaced by short circuit. Fine. So output voltage, please see carefully. The for output voltage, X is positive, Y is negative. So if you take here, so X is positive for output terminal and Y is negative. This is output voltage. Fine. So this circuit is basically small signal equivalent. So I need to find the voltage gain, that is ratio of output voltage by input voltage. Input voltage is Vs here. I am taking Vs. So how to find that? Output voltage will be this current is IC, that is coming via what? Coming passing through RE, then to RC, and coming this way. You can see this current IC will be moving or passing through these resistances and coming back this. So output voltage will be what? This resistance RE multiplied by this current HFE into IB. So RE into HFE into IB, you can see here, that is your what? Output voltage. I'll just remove and again clarify. The current here, this current IC is nothing but HFE into IB, is passing like this, going through resistance RE, going upward and then coming back this way. So it is going upward. This is the positive terminal, this is negative terminal. So V0 will be equal to resistance RE multiplied by HFE into IB. Why? Because this is my collector current here. This is the expression of output voltage. Fine. And from base circuit you simply apply KVL in the base circuit. So what will be voltage Vs? If you move like this, so minus to plus, it is voltage rise. So Vs minus, then it will be plus, it will be minus, that is voltage fall, because it is voltage drop across Rs. So minus Rs into Ib, and then drop across HIB will be what? Plus minus. The point where current enters is plus and point where current leaves is minus. So this is HF into IB, that is equal to 0. So that gives you the current, that is base current here. Fine. So I hope it's clear. So from here what we do, we have obtained the base current here, right? And we know base current is related with source supply now, and base current is also related to output voltage. So by putting this expression of IB in this equation, we get the output in terms of voltage Vs. Fine. I hope this is clear. Now let us see it further. Here we have obtained the voltage gain of the circuit without feedback loading. And if you see the input side, I need to find the input resistance without feedback loading. So we have obtained what we could find, voltage gain of the amplifier without feedback loading. And I need to find the input resistance without feedback loading and output resistance without feedback loading. If you see the input circuit from input side, I will go back again, see from this side. If you see this loop, that is nothing but, if you see the input loop, see this loop, I will go this way. So what is the resistance seen from this? That is Rs plus this resistance only. So on input side, the resistance without feedback loading is nothing but, that is Rs plus HIE, that is input resistance without feedback loading. Fine. So we have obtained voltage gain without feedback loading, we have obtained input resistance without feedback loading. Now we have to find the output resistance without feedback loading. Let us see how to find that. Remember, for finding the output resistance without feedback loading, we need to replace the input voltage source by short circuit, and we need to find the resistance seen from here, this side. This is the output resistance without feedback loading. So when you put input source equal to 0, so base current becomes 0, because there is no voltage source here, so base current becomes 0. When base current is 0, so this current becomes 0, HF into IB. So when current becomes 0, that is open circuit. So this will behave like open circuit, and when this behaves like open circuit, so this is opened here, so resistance seen from this side will be equal to this resistance only, that is Re. I hope funda is clear. I have written that language here, and this is your output resistance without feedback loading. So I have obtained what? I have obtained this, I have obtained input resistance, I have obtained output resistance. So what is desensitivity? And we have obtained beta. Beta was equal to 1. I can just take you back. This beta was 1. Let us come back again. So I have obtained beta, I have obtained gain without feedback, I have obtained input resistance without feedback, I have obtained output resistance without feedback. I'll just clean it so that it's visible to you. So now, what is desensitivity? Desensitivity is given by D is equal to 1 plus AB beta, and we know what is AB, that's there. So you simply replace AB into beta. Beta is 1, so we have obtained desensitivity. And for feedback amplifier, gain with feedback is what? Open loop gain divided by 1 plus AB beta. So you just replace it by this, or you can simply put AB and beta in this expression. You are able to get the expression of gain with feedback. Similarly, if you know this desensitivity AB into beta, I have already given you that. So you can find the gain input resistance without feedback. You know this, you know this, you know this. Fine. So this gives you the input resistance without feedback. Similarly, output resistance for voltage series feedback in voltage series, output side is shunt sampling, input side is series mixing. For series mixing, input resistance increases. For shunt sampling, output resistance decreases. So this is R naught by 1 plus A beta. So you know what is AV, you know what is beta, you know what is R naught. So by simply putting into this expression, I am able to obtain all the parameters of the amplifier. That is output resistance with feedback, input resistance with feedback, then gain of the amplifier with feedback, and sensitivity, of course. So this is all about your voltage series feedback. So in next video we will be seeing the voltage series feedback amplifier using FET. So wait for my next video. Thank you very much for watching the video.